Hello and welcome back. We are picking up our exercise practice here with exercise number 6. We're going to prove that n log base 3 of n is in little o of n cubed. So let's start by breaking down the problem and applying each of the properties that we want to apply. We'll go step by step, and here's hoping that we can come to a reasonable conclusion. Now, let's start by looking at our list of properties. Let me just scroll back up to our top here. And we're going to find a property that allows us to work with the fact that we have this log. Now, our log that we have is on this side of our big O, or sorry, little o formula. So let's go ahead and grab this property right here and pull that into our exercise there. Okay, so by that property, if a is going to be greater than 1, which it is, then we can say that log base a of n is going to be in little o of n to the b. So since log base a of n is a logarithmic function with our base, let's take a look right here. We have our base a being 3, which as we know is greater than 1. We can use this function here. We can use this property here. So what that actually means for us is that we can say log base 3 of n is going to be in little o of n to the b, right? And as long as b, for any b greater than 0, right? For any b greater than 0. So we can choose any b, including choosing the b to be 1. So let b equal 1. And what we'll end up with then is log base 3 of n is in little o of just n. Perfect. So this gives us the first piece of information that we can use. We could pick a larger b as well if we wanted to, but we're going to need, like, we could pick our b to be 3 directly, but we are going to need this fact later. So let's just leave it for now, and let's go and grab the other, where is it? The other property, this one, that we've already used a few times to get this in little o of n cubed. So if we use this property here, we can say by 1.3, like this, 1 is less than 3, therefore n is going to be in big O, little o of n cubed. Okay, so now that we have these pieces of information, let's just highlight the pieces of information we have so far. We have this piece of information that we pulled from here, and we have this piece of information that we pulled from here. And so now let's go ahead and find a property that will allow us to combine this information. Now, the reason that we had to do it like this, just as a reminder, if it's not obvious, is because we do have just this n over here that we have to work with, and we have to work with this log base 3 of n. And we have to be able to show that n is in n cubed, which we've now done. And we have to be able to show that the log 3 is in n cubed, which we have now done. So we had to break this up right here, break these two terms up so that we could show both were in n cubed. And then when we go back to our list of properties, we can find the property that involves multiplication. I think we want this one, since this is the one that has the little o in it. So let's pull that in, whoops, right here, make it a little bit bigger. And we can see what it says. It says that we can apply this property here where f1 is in little o g of 1 and f2 is in big O g of 2. Then both together, multiplied together, will be in little o g1, g2. So what can we say? Well, from step 1, we know that log 3 n is in little o of n. And this right here is this. And we can say from 2, n is in O of little o n cubed, which is this part. If we need the reminder, we can go back up and show right here that if it's in little o, it's in big O. So we can pull that one in again. We did this in the previous one right there. So we can say from 2 and 3.4. Therefore, n is going to be in big O. If you want to do that, you can. And now that we have all that information laid out, we can say it follows that, let me make sure I have all my information here. F1, which is n, and F2, I guess I have them backwards, but that doesn't matter because it's just multiplying them together is going to be n times multiply these two functions together to find that we are in n big O of n cubed. And therefore we have proven what we set out to prove originally. Now, I will say that I notice one little discrepancy here, which is that if I would have proven both in n cubed, like n cubed times n cubed, this should have been, so this step here should have been 1 less than 2, which would allow me to do this. N is in little o of n squared. And if n is in little o of n squared, then it's in big O of n squared. And in that scenario, we can basically multiply them together, where we take our original n and multiply it by n squared, which would give us little o of n cubed. So I'm just going to highlight this because I did mess that up a little bit, and I want to make sure that we understand where these values came from. That came from there. This came from there. This came from, oops. This came from there. This came from there. So altogether, we can then prove that our entire statement is in little o of n cubed. Apologies for that there. So we multiplied everything together, right? F of 1 in little o g of 1 and f of 2 in little o g of 2. Then we can multiply f of 1 and f of 2 together, and it will be in little o of g of 1 and g of 2. So we did exactly that. We multiplied n and log base 3 of n. We multiplied n squared and n, and we ended up with n log base 3 of n is in little o of n cubed. Awesome. Whew. As we continue to sort of blow through these here. Okay, so thank you for joining me on that one. We're going to go look at one that's a little bit trickier next. We're going to look at one that has to do with exponentials right here. And exponentials are kind of more so in this very intensely abstract space. So join me in the next video where we will take a look at exercise 7 and exponentials. Thanks. Have a great day.